In today's lesson, we're going to take a look at the use of the graphing calculator in order to solve systems of equations and application problems that use systems of equations. In our first example, I just want to show you how to use your graphing calculator. So I've given you two equations to form a system, one of which is already solved for y, the other one isn't. If I take a look here, I want to actually solve the first one for y. That's the only way that I'm able to put it in my calculator. So if I solve this for y, I would get y equal to negative x plus 3. This one is already solved for y, and so I don't need to solve that one. I need to put both of these into my y equals of my calculator. So step 1 is to put it into the y equals button. And then to enter your equations. So you're going to enter equation 1. Into the y1 of your graphing calculator. And you're going to enter equation 2 into the y2 of your graphing calculator. And you can see I've done that already here. Instead of putting 3 divided by 2, I just put in 1.5. So type that in your graphing calculator. And the next thing I want to do is hit graph. So go ahead and hit graph for me. I'm going to write out that our step is to hit graph. So I want to hit the graph button. And if you don't have a good window, you might want to zoom. So I'm going to hit my graph button here. This is what your graph should look like. If your graph doesn't look like that, it's because your window is different. In order to change your window, you're going to hit zoom 6. That'll give you the same graph that I have. Okay, so zoom 6 to get a standard graph. So I went to y equals, we'll just review, y equals, I entered in my equations into y1 and y2 after having already solved them for y. Then I hit graph, and if my window wasn't great, I hit zoom 6. The goal in any system of equations is to find the point of intersection. So I want to actually calculate my intersection point. To do that, I'm going to hit the second trace button. And the reason I'm hitting trace is because up above it, you'll see that it says calculate. And I want to calculate something of my graph. So I'm going to do that now. Second trace. And of these options, it should be really clear which option I want to pick. Okay, I want to select the intersection option. So I'm going to hit number 5 or arrow down to intersection and hit enter. Okay, so I'm going to do the arrow down and hit enter. You could have hit just number 5. It's going to prompt us for a couple of things. I want to be anywhere on my first curve. Well, it says y1 up here, so I'm going to hit enter. Then it moves my cursor down to my second curve, which is where I want to be. It's prompting me, what's your second curve? Okay, I'm going to hit enter again. And then I'm going to arrow over. It's asking me for a guess. I want to get to that guess, that estimation of where my intersection is, and I'm going to hit enter again. This tells me my intersection is at 2, 1. So a couple of things. What we did here for step 7 was we hit enter three times. Okay, we hit it one time for my first curve. I hit it a second time when I was on the second curve. And I hit it a third time for my guess for my point of intersection. Okay, final thing is to write down your answer. Okay, so if I come over here, I want to identify the answer to this solution based on what I just found is 2, 1. So my answer is the ordered pair 2, 1. This would be my answer. I didn't have to do very much algebra. I did have a little bit here because I had to solve for y. Okay, let's apply this in a harder setting. So in this second example, we're going to use the graphing calculator to solve application problems, and we're going to bring back into play our ability to create linear regressions using the graphing calculator. So our scenario that we're presented with says that winning times for the Olympic 400-meter run have been decreasing more rapidly for women than for men. We want to use the data in the table to find linear models for the women's and men's times. Assuming that these trends continue, we want to predict the year in which the women's winning time could equal that of the men. So let's interpret what they're asking us here. If they're asking us to predict the year in which the women's winning time could equal that of the men, as soon as it wants us to create equal scenarios, that is going to be a system. So that means we want to create a system of equations where we want one equation that represents the men's time, and then we want one equation that represents the women. Okay, let's take a look at the other thing that we're given. We're given that x equals 0 in 1968. That means we really don't want to use these years in our graphing calculator. Instead, we want to represent them with values of years since 1968. So in 1968 it would be 0, 1972 would be 4, and then so on. I will enter each of these x values, into my list 1. And then for my men's times, I'm going to put them into list 2. So to review again in my graphing calculator, so on my calculator, I'm going to go to Stat, and I'm going to go to Edit, and I'm going to enter in my list 1 and 2, the list 1 the x values, and the list 2 the men's times. And I've already done this here. So hit pause if you need to and enter those in. Now I'm going to quit out of here so I can calculate my linear regression. I'm going to go back to Stat, then over to Calc, and then down to number 4, linear regression, and hit enter. This gives me my linear regression equation for my men's times. So I'm going to write that, and I'm going to record as much as I can. So y equals negative 0.02433, and don't forget my variable x, and then plus my y-intercept, so 44.428. Okay, I'm going to do the same thing for my women's. So go back, and instead of entering my L2 for my men's times, replace that list with my women's times, and see if you can get this equation. Y should equal negative 0.08883 times x plus 50.86. These two equations now become my system, and again I want to find where they're equal. So now I want to use my graphing calculator to determine where these two equations are equal. So we just learned how to do that. I'm going to go to my y equals, clear out anything if you have anything in there, and type in exactly what you have for y1, or your equation for your men's times, X is up here if you're looking for it. And then down and hit Y2 to enter in your second equation for the women's times. Since I know that my y-intercepts are so large, I'm going to change my window. Before I graph, I know I'm not dealing with any negative years. I'm going at least all the way up to 32, and it's going to take a while. So I'm going to give myself even 200 years. Okay? I have no negative times. And my times here, actually, I'm even going to shrink my window. My smallest time around here really doesn't seem to be anything lower than the 40s. And my highest time doesn't seem to be anything bigger or even close to 60. So I'm going to make that my min and my max. And let's take a look at what my graph looks like. Okay, I can clearly see my point of intersection, and that's what I want to calculate. So second, trace, and down to 5 for intersection. I want to be anywhere on my first curve, and it shows me I am Y1, so hit enter. It moved me Y2, so I'm going to hit enter again. And then I want to guess, so I'm going to arrow to the right so I can get close to my guess. And I'm going to hit enter. Okay, my point of intersection then, my answer, if you will, based on my calculator, is 99.7, comma, 42.0. So when I wanted to predict the year in which the women's winning time could equal that of the men, I really need to say that I want 99.7 or 100 years since 1968. That tells me in 2068 they will have the same time. And actually, if you wanted to know what time that would be, right, it'd be a same time of 42 seconds. So it's going to take a while before the women even ever catch up to the men, even though the women's times have been decreasing more rapidly for women than men.